everyone. I'm going to have my talk in English, if that's okay with you. I'm going to be talking about very large development, how to manage over 1,000 contributors in a Python open source project. That's a long title. First of all, a little bit about me. My name is Gerrit Rahme. I work at Innovance in Paris for a web hosting company, where I'm mainly paid to work on OpenStack and contribute to OpenStack. Personally, I've heard of Python for a long time, but I've been using professionally for 3 years now, and well, this is what I'm going to be talking about. What is this talk? It's about quality assurance for large teams, and specifically in the example of OpenStack. What do I mean by quality assurance? I mean two things. On one hand, we want to detect errors as early as possible and try to fix them as early as possible, but on the other hand, we still want to make it easy enough to contribute so that the entry barrier is very low. One thing we're going to talk about as well is the pitfalls of Python at a large scale, especially when so many contributors are participating. And in all fairness, this talk is inspired by a talk that Joe Gordon has given. I saw him in EuroPython. It's called Very Large Development, How to Run Code Review for 800 plus open source Python developers. It was less at the time. Joe is on the team, it's called OpenStack Infrastructure. He's part of the team that sets up all the architecture that I'm going to present here. And in his talk, he explains why they made the choices that they're going to make. I'm going to give the counterpart point of view, the point of view of the new contributor that just got to the project and wants to discover it and how, well, what is going to appear. But just by show of hand, I'd like to know who here knows of OpenStack, or who doesn't know of OpenStack? It's going to be easier. Well, very few. Okay, who here has contributed to OpenStack already? Also very few. Perfect. Other question, who here participates in an open source project? I'd say about 2/3. And who here participates in an open source project with more than 20 active contributors? 4, 5, well, 5, 6 people. Well, OpenStack is a lot larger than your usual open source project, and this is what we're going to be seeing. So what is OpenStack? It's a cloud computing project providing infrastructure as a service. If you don't know what infrastructure as a service is, it's a way to manage data centers when we offer our customers the way to launch virtual servers, but also networking equipment, storage solutions, and all that. It's a project that is relatively new. It started in 2010 when it was when two different projects, one at Rackspace and one at NASA, merged together. Since the community has grown so much in the past few years, the project has adopted a governance model that is very close to what the Linux Foundation does, and by creating a non-profit organism called the OpenStack Foundation that manages this community and deals with what needs to be dealt with. And we have contributors from literally so many different companies that you cannot count them, and big names as well. Like, I'm sure you know all these names. But OpenStack is mainly lots and lots of Python code. We're talking about a huge project. And here's a small little overview. OpenStack is segregated into many different projects. For instance, you can see the compute part, which is in charge of virtualization, but also networking, storage, single identity project that provides identity and authentication for all these projects. And each project provides its own API. And if you don't want to use this programmatically, there's the dashboard, which is a Django web app where you can go click, 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 click as much as you want. But to be honest, this project is extremely minimal. This diagram is extremely minimal. To be a little more fair to OpenStack, I could do something like that. And even then, I'm leaving out a lot of new projects that got included. And if you take into account stuff like high availability and replication of all these processes, you have a lot of code and a lot of software running on a lot of machines. Okay, some numbers about OpenStack. I went on the website olo.net. Olo is a website that compares open source communities, and here are some numbers. You can see as you can see, they're pretty huge. Like, in 3 years, we have over 90,000 commits, over 1,500 contributors, over 1.5 million lines of code. And only in the past 30 days, the numbers are also in thousands of commits, hundreds of contributors. It's pretty big. The point is, I don't want to spend too much time talking about OpenStack itself, but just to get the idea clear that we're talking about larger scales than what the other projects I've been part of, at least. Now about Python. Python is a wonderful language, and I'm not going to spend too much time telling you how wonderful it is. It's PyCon. You're already sold to the language. So we're going to talk about the problems it has. Static typing is the most obvious one, especially at this scale. And static analysis in general makes it difficult to detect certain kind of error that can come and bite you later on. No interfaces, no encapsulation. Generally speaking, we're all consenting adults mentality that is rampant in Python is a problem. I give the example of encapsulation. How do you make a variable private in Python? You prepend an underscore. But nothing in the compiler or in the runtime prevents anyone else from accessing this variable. We're all consenting adults. Well, when we're thousands of adults, someone is going to make a mistake somewhere. And no built-in concurrency, that's a recurring topic. OpenStack uses eventlet and kind of make do with it, and it's okay. So as a contributor, you get to OpenStack, you wanna send the patch. The first thing you wanna do is set up a dev environment. The first thing you want is build an OpenStack against which you can test your change. You wanna do this in a virtual machine. Well, I'm gonna open a small parenthesis here and say, if you're anything like me, you don't know anything about virtualization and probably don't want to know a lot about it because you want to get started. I discovered this project called Vagrant. I strongly encourage you to check it out. It has nothing to do with OpenStack, but for people like me who sometimes need to launch 2 virtual machines and have a small network run between them, it's a life changer. So check it out. Then OpenStack uses Git as source control, and there's not much to say. We're not going to talk about the whole distributed versus centralized. I think that now the distributed model is kind of won, and it makes sense to use it. As far as contribution, the entry barrier for contribution, Git is the only skill you will need to have that, because you will need to do some advanced and not really advanced, but some techniques like rewriting history or cherry picking certain changes. These kind of things are expected of you, but since Git is pretty big and used in so many projects, I think it's fair to ask that from your contributors. And finally, and probably most importantly, DevStack. DevStack is a bash script that will install a minimal version of the product in your VM. There are 2 things I want to talk about DevStack. First of all, it's written in a kind of literate programming way where comments are extensive, and it's more than just comments. It's literally prose that is explaining what is happening at each time. As a newcomer, if you're launching DevStack, and it takes 45 minutes to install on my laptop with a good internet connection, spending some time reading is a great introduction. And the second point I want to make is, if you have an open source project and you want to attract contributors, you want to make it easy to build. I cannot stress that enough. If it's difficult to build, people aren't going to contribute. We're programmers. We don't like building things. We like living in our text editors, writing code, committing, but not building. And something as complex as OpenStack, I do not want to learn how to build it before I have to send the patch. Then, well, writing the code, I'm writing my changes. The first thing I want to care about is testing. I'm not going to go over how important testing is, but at least in OpenStack, it's prevalent. It's everywhere, and it's very important. No patch is accepted without the appropriate unit tests. And as someone who comes to the project at first, it's great to be able to just check out any project and run the unit test suite and see that, okay, we have good coverage. So if I change and I break something, I'll be able to catch it very early. It gives you confidence to just change the code. Functional tests are a little different. They're not just testing the code, but they're testing functionalities, and they're usually tested against a live cluster. In OpenStack, they're dealt as a separate project. And it's used, of course, to validate that changes aren't introducing regressions on your features, but it's also used by our ops people who deploy OpenStack at a customer and then want to make sure that all the features are available. Functional testing is good for that. The third kind of tests that are run is style. Well, style is a controversial issue sometimes. Fortunately, in Python, we can pretty much all agree on PEP 8. And this is great. And there are tools to make sure that your code is PEP 8 compliant, and we use them in our tests. PEP 8, so the tool is appropriately named PEP 8. That's no surprise. I mentioned two other tools, Fleck 8 and Pylint. They do static analysis of your code, which means trying to detect errors in your code without executing it. At least for Pylint, we're not using everything. If you've ever used Pylint, you know that it will give you so many different errors that you cannot solve them all. So we're using a subset, and we defined more or less between these three what is the style you want to have. The kind of error that is caught by Flake 8 or Pylint, I think it's Flake, it's like you declared this variable and never used it, or why are you importing this module, or stuff like that. And the last project I want to mention is Tox. I don't know if you're familiar with Tox. Tox is a virtual env manager. It allows you to run your tests and other things in different virtual environments. So it's very useful for us. We need to have support for Python 2.6 and Python 2.7. Tox allows us to deal with that without having to do it manually. So you wrote your code, you wrote your change, you wrote the tests, and now you want to commit. And we're in OpenStack, this is what we use. We use Gerrit, which is a web-based code review app. It's based on top of Git. It originated at Google, and they started using it for Android, and now it's becoming more and more prevalent and used by many big projects. The main idea of Gerrit is to centralize the usage of Git and have a single authority say, like, I'm going to manage what is going to go to the trunk. And if you're familiar with GitHub's pull request, it acts a little differently. Pull requests in GitHub ask you to merge a branch. Gerrit will act at a commit level and say, let's improve this commit until it's good enough. You know, maybe I can show you here. Well, it's going to be a little, okay, here we go. So this is the Gerrit interface. This is a patch I submitted a while ago. Here you can see the commit message of my patch. Here you can see the score, so random reviewers will come and say like plus or minus, or here's what you should change. Usually a patch isn't approved until at least 2 core reviewers say okay. Here you can see the different patch set I sent and all the back and forth that has gone through, each one incrementally improving. And here are the comments of all the discussion that went on to reach this final state that is okay. So basically, this is Gerrit. Unfortunately, I don't have much time to show you more in depth the advantages it gives. So we're going to move on, but feel free to come and ask me at the end. So we sent our patch to Gerrit. What is going to happen next? The first thing that happens sorry, I forgot. So I put this slide just to say that descriptive commit messages are important, and you have to keep in mind that whoever's going to review your patch doesn't necessarily have the context in his mind. So it's great, and you use the git commit message to keep track of all the context we want to have. Here you can see, for instance, like referencing another commit or mentioning that both of these commits are temporary, or this is the kind of info you want to give your reviewer so that he or she can make the proper decisions. And I want to mention Git review as well. Committing to Gerrit is not very difficult, but it might be error prone. And when we're talking at a scale of thousands of developers, might be error prone means the error is going to happen, you're going to lose time, and you want to avoid that. Git review is just a Python script that makes it easier to commit to Gerrit. and it's written as a Git submodule. It got so popular in the community that it published on PyPy in its own right as a separate script, and it's becoming used in other projects as well. We're going to talk about this later, but this is something that is great about OpenStack. If something is useful, make it reusable. So we talked about committing, and you sent your patch to Gerrit. The first thing that is going to happen is a continuous integration. We use Jenkins for that. Jenkins is just this robot that runs batteries of tests constantly against the code. Every patch that is submitted, actually Jenkins is your first reviewer. The first review you get in Gerrit is from Jenkins saying, I ran all the tests, they pass. Or if they didn't pass, here's what you should check. There are obvious good aspects of Jenkins. The first one is that having this mechanical testing allows you to detect errors as early as possible. And there's another part that I discovered in OpenStack. It's increasing confidence in immature projects. For instance, I know a while ago, the networking project it's not that it had problems, but it was young and relatively immature. It's very easy to write a testing scenario that you would qualify as non-blocking, run it against all the new patches, and start looking at where are the most common errors I'm getting. This helps you to get increasing confidence of, like, once I deal with these errors, all the new patches will pass. I feel like this project is mature enough. The bad parts of continuous integration, number one, and probably the most obvious one, is that it requires a lot of processing power. We're talking about running tests against so many different patches. Like in the past 30 months, 4,000 patches. Each patch has so many reworks and new patch sets that are sent constantly. A lot of patches are abandoned, so they're not included in statistics. So you need a lot of processing power to run a proper continuous integration. The other problem I found is that breaking the gate will handicap everybody. The gate is the first review done by Jenkins. Is as soon as you submit your patch, you run the test. Say for whatever reason, I introduce an error in my tests. Now all the patches that are currently queued in the continuous integration will fail. And I will handicap everyone until I fix my error in my test. This doesn't happen often. In the 8 months I've been working on OpenStack, it maybe happened once or twice. I think twice, and once it was solved pretty easily and pretty quickly. But sometimes if you're dealing with subtle bugs like mixing dependencies or something like that, it can like we spent once 24 hours where we couldn't commit. Once your patch is accepted, it's merged into trunk. And we use GitHub to mirror. GitHub is a great publishing platform. Since it's using Git, it's very easy to clone our code to them. And OpenStack, as far as I know of, maybe there are more, but as far as I know of, there are 3 accounts that OpenStack creates on GitHub. It's OpenStack, OpenStack Dev, where we store all the utilities used by the devs, for instance, DevStack, that I mentioned earlier. Stackforge, I'll talk about Stackforge in a further slide. Now communication, I left communication until the end, not because it's not important. I honestly think it's the most important part, but I also think that OpenStack, its biggest weakness, because we have a proliferation of so many different techs we're using, whether mailing lists, extremely active mailing lists, IRC, Launchpad to use to track bugs and track blueprints. Blueprints are requests for a new feature, kind of like the PEP in Python. Ask OpenStack, which is a Q&A website similar to the Stack Exchange network. We have this proliferation, makes it very difficult to know where should I ask my question or where should I search for for answers to this question before. I'm hoping that this problem we have with proliferation of communication method will one day will be taken seriously, but I also think, just like the XKCD strip I mentioned, I also think that it's going to be very, very, very difficult to unify everything. People have their habits. They've been doing this for this whole time. We're not going to change one. So that's it. Finally, I mentioned Stackforge and incubated projects. Stackforge is this project where every script or every idea or every utility that was created around OpenStack can be I wrote, useful scripts become projects in their own right. And that's the whole idea behind Stackforge. And most importantly, we give them access to all the QA system that I just described. Incubated projects are projects that are meant to become one day official OpenStack projects. They also go through the whole Stackforge and they get access to the QA before becoming official. I mentioned two examples. PBR. PBR is this, it started as a bunch of Python code that set up the build systems and defaults that was cloned every time we started a new project. We packaged it, we put it in Stackforge, and now it's available on PyPy if you want to start a new project. Another example is hacking. Hacking is the glue we're using for our style checkers. I mentioned we use 3 different utilities for style checking. Hacking glues them together, sets some configuration. And like for me, who like the style checks and the style guideline of OpenStack, having hacking available on PyPy makes it available for my other projects. And this mentality really helps the developer, first of all, feel welcome. Second of all, feel familiar with the habits of the community. And this is very, I mean, I think if you have an open source project and you have these small utilities you use particularly for yourself, try to make it reusable, and it's gonna help out a lot to get contributions. So that's my presentation. I hope you liked it, and if you have any questions, feel free to ask.
So you said you checked for PyPy compliance in the tests, and I wondered how you dealt with the non-backward compatibility of PEP 8. And by this I mean about last year, about this period, they released a new version of PEP 8, and it started raising a whole new bunch of errors. And when you have a code base which is quite large, so for instance, this happened to us on Matplotlib. We started moving all our code to PEP 8, and then suddenly there was a new release, and we already had changed, I don't know, 50,000 lines of code manually. How do you deal with this?
But to be perfectly honest, I've never come across something like that. But I know that hacking allows you, at least, allows you to turn off certain checks or make them non-blocking. And this is a great way to help you like, ease into the change. But as far as I know, that's the best you can do. I know we do something similar for Pylint, where a lot of checks it would be a nightmare if they were blocking. So we just disable them. And maybe Julien wants to add something.
Yeah, actually what we do in hacking is that we bind the PEP 8 version we want to use. So we validate with one version, and when a new one is out, we test it on Edgeworth, and we pre-commit the fixes for the new version. And we then upgrade the version we want of PEP 8.
Okay, thanks. Good answer, Julien. Any other question?
Hi, you mentioned that you have many quality checks, which is very interesting, but there's a missing point, maybe which wasn't mentioned. How about code duplication? I know historically there was a lot of code duplication in OpenStack. How do you deal with it?
As far as I know of, you don't. I've actually seen code that duplicates in other parts of code, and it got accepted. I think there's only so much you can do. Maybe it is a problem and we should deal with it. But you have to remember that things are at large scale, so the people reviewing your patch don't necessarily know that there are code duplication elsewhere. And as far as static analysis goes, I don't know of anything that is able to do this on Python. If there are, I'm interested in knowing. We can probably do something similar with Pylint if it's confined in a single file. But if it's in several modules, I don't know. I wish I had the answer.
Because I had in thought OpenStack Commons, which was a long time ago copy-paste in other projects. That was a sample I had in mind.
Thank you.
Yeah, but that's it. It's still a lot of manual human review, and with a little bit of luck, if core reviewers become core because they made a lot of review. So with any luck, if they come across and they will detect it, they will help out. But that's the best we can do so far. Or at least that's the best I know
of. When you were talking about Jenkins, you mentioned that you need a lot of processing power. And in a later slide, you were talking about the QA infrastructure. I'm wondering, can you just elaborate somewhat about, I mean, where those systems are and who manages them, and what do you do about outages? I mean, if obviously you made the point about it's a large project, and I imagine that outages and system admin, if it's not working well, it can cause problems. So I'm just wondering who manages that, I know the foundation, obviously, but I'm just trying to say physically, where is that, and how does that work for you guys to get that going and have it running all the time?
Okay, to be honest, I don't know where the servers are and where are they managed. But as you mentioned, first of all, it's the foundation who would deal with something like that. I know from my part, I know that in the community there there's a team called OpenStack Infrastructure who manage the day-to-day running of the platform, basically. I don't know who funds it particularly. That kind of things I don't know. But as far as managing, yeah, the team exists. They're easily reachable.
So the process is in place, and if there's a problem, you guys know who to.
Oh, absolutely,
who to
absolutely.
To get it resolved. Okay.
As far as processes go, yeah, they're available. Like you can just spend 2 seconds on the wiki or on the documentation. You will find how to reach them. They're available on IRC all the time. They have their own mailing lists, so we can reach them. I just don't know where the servers are. Julien wants to add something. Julien knows a lot more about OpenStack than I do. He's been here before me.
Yeah, most of the processing power which is used for Jenkins is provided by HP and Rackspace. So Jenkins is used to instantiate new cloud servers and to run tests. So we have both providers for this.
Okay. Other questions? That's it, I guess. Thank you for listening to me.